In this video lesson, we are going to look at the application of distance. Now, we're not going to do any theory, we're just going to work through a few examples. So the first example, it says triangle PQR has vertices P at 2 and 2, Q at 4 and minus 4, and R at 7 and minus 3. And then it says calculate the perimeter of triangle PQR. So the perimeter is basically the distance right around the shape, okay, if you remember from measurements. So what we need to do is obviously to find the distance from P to R, then find the distance from R to Q, then find the distance from Q to P, and then basically add them all together, and that would give us the perimeter. So first of all, I'm going to start and just find the distance of PR. So PR is equal to, so if I just write down the formula, the distance formula, in terms of P and R, we've got x of P minus x of R squared, and then plus y of P minus y of R squared. And then just substitute that in. Then we get, so where is our coordinates? We've got P and R. Okay, so I'm going to say 2 minus 7 squared plus, and then for the y values, 2 minus negative 3. And that is all squared. And take the square root there. And then to simplify, this becomes 2 minus 7, which is negative 5. So minus 5 squared is 25. And then plus 2 plus 3 is 5. So that is going to be also 25. 25. Okay. And then that is squared. Okay, so if I put this onto the calculator, then I get square root of 25 plus 25, and that gives me 5 square root of 2. Okay, now for the next one, we are going to calculate the distance from R to Q. So we can basically say, okay, let's say QR, so QR, and then write the formula x of Q minus x of R squared plus y of Q minus y of R squared, and take the square root. Okay, and then substitute in. So Q and R, so it's 4 minus 7 squared plus, and then minus 4 minus 3, or minus negative 3. So minus 4 minus negative 3 all squared. Okay, now 4 minus 7 is negative 3, so negative 3 squared is 9, plus minus 4, this becomes a plus 3, so minus 4 plus 3 is negative 1, and negative 1 squared is 1. Okay, then we take the square root, and this will give us the square root of 10, which I believe is in the simplest third form. And then finally, we just need to find the distance of PQ. So PQ is equal to XP minus XQ squared plus YP minus YQ squared. And the square root of that. And then we substitute it in. So we have this 2 minus 4 squared, and then plus 2 minus negative 4 squared. So 2 minus 4 gives me negative 2. Negative 2 squared is 4, and then 2 plus 4 is 6. 6 squared is 36, and then we type that into the calculator, and we have the square root. So 4 plus 6 is 4 plus 36 is just basically 40. So I'm just going to say 40, and then it's 2 square root of 10. Okay, now just to find the perimeter, so we can say perimeter of triangle PQR. That is now just equal to all of the sides added together. So we've got 5 square root of 2 plus square root of 10 plus 2 square root of 10, and then we can type that into the calculator again. So So I have 5 square root of 10, 2, sorry, it's going to be 2 plus square root of 10 plus 2 square root of 10. And this one, I'm just going to type this as decimal places directly. So if I say SD, then it gives me 16,56. Okay, so 16,56. Alright, now for B, state whether the triangle is scalene, isosceles, or equilateral. Now a scalene triangle is one that has no sides equal to each other. Isosceles has 2 sides equal to each other, and equilateral has all 3 of the sides of the triangle equal to each other. So we can see that from these that none of these are equal to each other. So for B, let's just go to the next slide. For B, we've got that it is a scalene triangle. Okay, and then for C, show that triangle PQR is a right angle triangle. Now, if we look at the sketch, we can see that this almost looks like a right angle triangle. And normally when we are given this question, and especially if we are not given the information above, let's say we are just given these coordinates and we have to show that it's a right angle triangle, what we would normally do is, we will see in a future video, is that you would go to gradient first, okay, because gradient has to do with parallel and perpendicular lines, but you can also do it with, if you know the distances. And the reason why you can do it is because of Pythagoras theorem. If we have Pythagoras theorem, r squared equals to x squared plus y squared, and that holds for our triangle, if we can prove that, then it is a right angle triangle, okay, because it only works in right angle triangles. So first of all, I want to show that PR squared is equal to PQ squared plus QR squared. So I'm first going to work out to calculate what is PR squared. And we calculated PR, so we saw that PR is 5 square root of 2. So I'm going to say 5 square root of 2, so all squared, okay. Now you can type this in your calculator, but basically what happens is you square the 5, you square the square root of 2, that becomes 25, and that just stays 2, so this is going to be 50, okay. And then we want to know, okay, what is PQ squared plus QR squared? So PQ squared plus QR squared, and then substitute in those values. So we saw that PQ is 2 square root of 10 and QR is just square root of 10. And if we substitute that in, we've got 2 square root of 10 and plus just the square root of 10, all squared, okay. And then if we square the 2, that's 4. If we square the square root of 10, that becomes 10. So 4 times 10 is 40, plus these two cancel each other, so that's just 10, and that is then also equal to 50. So we can see that PR squared is 50, PQ squared plus QR squared is 50. So therefore we can say that PR squared is equal to PQ squared plus QR squared, okay. And therefore we know that triangle PQR is right angled. Alright, then we're done with that one. So now let's look at example 2. Calculate the values of y for which the points s, 3 and minus 2, and t, minus 5 and y are equidistant from u. Now it helps to actually just do a rough sketch in pencil of what's going on here. So if we can look at this, we see that s is at 3 and minus 2, so that's like more or less over there. So that's going to be s 3 minus 2, and then we have u, which is minus 2 and 1, so basically more or less there. And finally we've got t, but we don't know what the y value is. So this is where we have to calculate the y value. All we do know about t is that it's the same distance as s and t is from each other. The same distance t and u must be from each other. So all we know about t is that it lies here somewhere at -5. This is the x value, which means it kind of lies somewhere on that dotted line, must be the point of t. But the only condition is that this line, the distance of this line, the point must have the same distance. So for example, it can't lie there because we can see that these distances aren't the same. Okay, but obviously we need to calculate that, do the calculations for that. We can't just assume from even sketching it. Okay, now first of all, what do we want to work out? If we can calculate what's the distance between US, we can know, okay, what the distance is between UT, and then we can also use the distance formula to basically substitute in the known distance for UT, and our only unknown will be y. Then we can basically solve for y using that formula. So first of all, I'm going to say, okay, what is the distance US? US, the square root of x of u minus x of s squared plus y of u minus y of s squared, and then substitute that in, s and u. So I'm going to say -2 minus 3 squared plus 1 minus -2. So that's squared. And then this becomes 5 squared. So this is 25 plus this is 3 squared, so that's 9. And I'm just going to leave it for now as square root of 34. Okay, that is then our distance. Then we can use the distance formula for ut because we know everything except the value of y. So the distance formula ut is equal to the square root of x of u minus x of t squared plus y of u minus y of t all squared. Okay, and then substitute it in. So x of u, so -2 minus -5 all squared plus the y value of u, so 1 minus y in terms of y. Okay, and then another thing is we know this distance of ut because it's the same distance as us, so we can substitute in the square root of 34 in place of ut, and that means that the only thing that we don't know in this entire equation is the value of y, and then we can solve for it. Now the first thing I'm going to do to get to y is to get rid of the square roots, because we've got this entire left hand side squared rooted, and then the entire right hand side. So I can just take the square root of a square of both hand sides entirely, and that will just cancel the roots. So we're left with 34. Okay, and then inside here we've got -2, this becomes +5, so -2 plus 5 is 3, and 3 squared is 9. So you can, if you want, to just type all of that in the calculator, but it's not hard to calculate that. Plus, and then here I'm going to multiply the brackets. Be careful not to just square like 1 and square y and that's it. It's FOIL. You have to either write out the bracket twice and FOIL it, or you need to do it the faster way, where we're going to square the first number, multiply them together, multiply by 2, and square the last number. So this is going to be 1 multiplied together is -y, multiplied by 2 is -2y, and square the last one, so plus y squared. Okay, and then we just need to carry on and solve for this. Now we can see that we have a y squared, which makes it a quadratic equation. Okay, and what does this mean? This basically means if it's not a linear equation where you take everything to the one side and the constants to the other side, it's a quadratic equation. It means there's going to be two answers. Now, why would there be two answers? Because we know that at this point, okay, this line's distance and this line's distance is equal. But what can also happen is there can be a point here where the distance is also equal. So there can be a point on top here, so which also makes that equal. that is why we're going to actually have two answers. So always make sure that your algebra and your graphs, the graphical and the algebraic of your maths adds up. Okay, so now to solve for this, what I'm going to do is I'm just going to bring the 34 over to the other side. It becomes negative 34, but I'm just going to write everything on the left hand side. So I'm going to say y squared minus 2y, and then it's 10 minus 34 is negative 24, is equal to 0. Okay, and then factorize. So my factors of 24 is 1 and 24, 2 and 12, 3 and 8, and 4 and 6. 5 can't go in, and then 6 just starts here again. So to get negative 2 from these factors, that one's difference is too big, that's 5, and then here we've got a difference of 2. So to get negative 2, I'm going to say minus 6 plus 4. So this is then y minus 6 and y plus 4 equal to 0. And then to solve for y is equal to 6, or y is equal to negative 4. And that's my answer. So they have only asked for the values of y, so this is the final answer. If the question have asked for the coordinates of t, then we'd have to obviously go on and say, okay, no, but t is then either minus 5 or 6, minus 5 and 6, or t is minus 5 and minus 4. Okay, so just make sure to read your questions properly. And that is then it.